What is a standard identity in algebraic expressions? And more importantly, before we even learn the standard identities, we need to understand the concept of identities in algebraic expressions. Okay, so let's say we consider a case that we have two expressions. One is x plus 1 in multiplication with x minus 3, and then we have x square minus 2x minus 3. Okay, and we say that both of these expressions are equal to each other with a given condition or a disclaimer that these two are equal for all values of x. Whatever the value variable x can take, this equality holds true. And when that exists, then we say that, or we can claim that this is an identity. An identity in algebra means that when two expressions are equal to each other for all possible values of x, we define that to be an identity. Okay, so the simple question is that how do you really prove that this identity really works, that this expression on the left hand and one on the right hand, they are really indeed equal to each other? Well, there is one way to find that we start assigning some values to this expression. Okay, so let's say my first value is x equal. So first left hand, it becomes minus 1 plus 1 in multiplication with negative 1 minus 3, right? And on the right hand side, I got minus 1 square minus 2 times minus 1 minus 3. Now let's find out whether what this will result into. So minus 1 plus 1 becomes 0 times negative 1 negative 3, or in other words, it's all 0 because anything in multiplication with 0 is a 0. And on the right hand side, I have minus 1 square, which is 1, minus 2 times minus 1 becomes plus 2, and minus 3. So in the net result, it is all 0. So of course, they both are equal, right? So let's explore one more value. Let's say I have x equal 3. In this case, my left hand side becomes 3 plus 1 times 3 minus 3, right? Which is 0 because 3 minus 3 is 0, and this in multiplication with this 3 plus 1 becomes 0 in total, right? Same thing on the right hand side, I have 3 square minus 2 times 3 minus 3, which is indeed 9 minus 6 minus 3, and 9 minus 6 is 3 minus 3 is 0. So once again, we find them to be 0. So you can continue exploring like this, but for each possible values of x, we will find that this indeed holds true. So hence we say that yes, this is an identity, all right? Now just like this, we can identify many identities in algebra, okay? So where do you narrow down, where do you draw a line that these are the frequently used identities and these are not frequently used identities? And that's exactly the concept of standard identity comes and helps us, right? So there are three standard identities in algebra. One of them is a plus b square is equal to a square plus b square plus 2ab, all right? And the second one is a minus b whole square, and this one ends up to be a square plus b square minus 2ab. The only difference between the 1 and the 2 is here we have negative, and this negative resonates with this negative in the final expansion, okay? And the third one is, what if I have a standard product of the term a plus b times a minus b, and this results into a square minus b square. And keep in mind that as we are talking about a and b and so on, all of these we assume them to be variable in this case, all right? Now the reason we call them as standard identities is because these are most frequently used algebraic identities, hence standard. Okay, so we will go through one quick example of where exactly we can use standard identity, all right? So my one example could be, can you find the square of 108? Okay, now you will say that, well, it is not too bad. I can simply take 108 multiplied with 108. I can expand the multiplication. I can keep going like this. Well, that is one way, but you have to go through at least 1, 2, and 3 terms of multiplication. Then you add them, and then you find your final results, right? That, of course, is one approach, but there could be a faster method. And the faster method is, what you do is you divide this 108 into two parts, and that becomes 100 plus 8. And then you simply apply the case of identity number 1. Okay, because this behaves like A, this behaves like B. You are simply substituting the value of 100 or assigning the value of 100 to the variable A and assigning the value of 8 to variable B. Okay, so as I do this, I can simply expand this whole expression by simple expansion of using identity 1, and that becomes 100 square plus 8 square plus twice of 8 times 100. Now this is simpler to solve because 100 square is very easy. It is simply 100 times 100, which becomes 4 zeros in this case, right? 8 square is an easy square, 64. 2 times 8 is 16 times 100 is an easy multiplication, right? So sum total of all of this will eventually result into 11664, and that is our final answer on the finding the square of 108, right? Isn't that easy, right? Standard identities so much in our algebraic calculations. Well, this was one simple example. So we will end this brief discussion here with the concept that remember two things. Number one, in algebra, when you have two expressions and you say they are equal to each other, then that equality means identity. That is concept number one. And that equality should hold true for all possible values of x. Okay, that's our key point number one. And the second key point is right here that we define three identities, 1, 2, and 3. These are very standard identities that we can use depending on our needs. Okay, with that, we will pause here with this video.